Bear with us for a quick second before I start going off about how the midterm is going to work. Kyle's checking something. Kyle in class is checking something for us. Yeah, you're checking if there are any blank answers. None. Okay. So, update on the midterm. Today we will end up having quite a bit of a shorter class. We'll just kind of go over the semantics of function calls and probably call it after that in order for me to troubleshoot some of this midterm stuff. So I've found out just in the last few minutes, it looks like that if you started the midterm before I did the fix yesterday, it locked in all those blank incorrect questions that were like you just couldn't take the exam. But if you started it after I made those fixes yesterday, you should be okay. So in order to fix that for everybody else, what we'll probably end up doing is duplicating the midterm as it is now, and that will give everyone who didn't take it or didn't open it yet, that give everyone that did open it and lock in those blank answers kind of a fresh slate. You should just be able to take it as is. We should be okay. So what we'll do is we'll kind of go over the stuff for today, today's material, which actually we're quite a bit ahead right now. I was kind of going through the rest of the semester's coursework. We're looking really good, guys. We'll actually get to cover some fun special topics. But yeah, I'll probably pull one of you from online that was having problems and help me troubleshoot after class for a few minutes. It should just take a minute or two. And then I'll obviously send out a big announcement with actually how to take the midterm. But yeah, so for those of you that didn't even open the midterm yet, you actually should be okay to take it. You should just be able to open it and take it right now. So procrastinators, you kind of won the day today. But yeah, more on that. I'll send out a big announcement when we actually do troubleshoot it the rest of the way. But I think the takeaway is for now, if you haven't even opened it yet, you should be okay to take the midterm. If you did, before yesterday, then you might still have some problems, and we'll have that fixed this evening for sure. So we think we know what the problem is. Other than that, are there any questions? No problems. Do I have to take it again? Graham, no, you are all good. Yeah, if you already took it, submitted it, and there were no problems, you're all set. You won't have to do anything different. If you did have problems, then what we'll do is we'll duplicate the midterm. You'll take the second one, the duplicated one, which will at that point not have locked in your answers. Or not your answers. It won't have locked in the blank ones. So that should fix everything. We should be all good from there. Maddie was just telling me that this has actually happened in other classes before. So hopefully this gets us an easy fix and we don't have to start doing pen and paper stuff. I don't think anyone wants that. Having immediate grades is really nice. So sweet. Any other questions about that, about anything before we get rolling today? Cool. If you did miss the note about the midterm, just wait for that announcement to come out. I'll spell it all out pretty quickly after class today. So otherwise, let's kind of bang out these semantic rules today. That's kind of what we'll cover for the day, and we'll start talking about recursive functions tomorrow. And we should be able to wrap that up in one class, I think. Move on to type checking next week. So I think I gave everybody enough time to ask questions. Anything in the room? Nothing? Anything online? Last call for logistic type questions. Cool. Well, let's jump into it. So yesterday we left off, we were talking about well-formedness at the very end. We'll pick that back up on Monday in your recitation. You'll go over that again. So won't pick up there, but we'll pick up with the kind of closures and talking about function calls and function definitions. How do we add this to a programming language? How do we make our programming language work with functions, right? We introduce these closures. Closures are the values that function definitions take, and they wrap up the environment at the time of definition, right? We remember that fun acronym P, parameter, expression, environment, right? Easy way to remember it. How do we go about evaluating these things? We did quite a bit of practice, just kind of got a feel for them in class, but how do we formalize this with inference rules? Do we think we can do this for function definitions? So let's start there. per usual, let's start with a big old horizontal line for our inference rule. And then for function definitions, we're going to keep with the normal syntax. So we have that sigma. So in the environment sigma, or in the context of sigma, whatever language you want to use, we have fundef of x, which is that parameter, and the body expression e evaluates to what? Does anyone have any ideas here? So actually it should be a pretty straightforward rule to write. So we need to get a value from a function def. Yeah, so Graham's saying closure. Graham, what else goes with that closure? Or what goes inside it, right? Yeah, so the n environment. Which environment though? It's going to be that sigma. So at the end, we'll have that sigma. But what else does the closure take? What else? Yeah, there you go. What else does that closure take? So that's the last argument. What else are we expecting? We look up here, we're expecting a string and an expression. What string and what expression should we put there? String should be X. Yeah, the string should just be X, right on. And what expression should we put there? E, just E. This is like the most simple, easiest rule we've probably written. Let's say simple. It's not the easiest necessarily, but the simplest rule we've probably written yet, right? All we're doing is taking the function definition under a certain environment, wrapping it in that closure. It's exactly what we said in kind of the English and the prose when we were talking about it. Now we've just done this as a rule, right? No premise is necessary, right? I don't need to say anything else up here. There's nothing about E, there's nothing about X that need to be true for this to work, right? It's later when we do function calls that you might see errors start popping up. Cool. Any questions about this rule? Aaron, I saw a quick look of question. No, nothing.
So you don't have to prove that like X is a value.
Yeah, you do. So, well, for X you don't. For E, you don't even have to prove that does yet because it's still missing that X piece, right? And so until it has an X, we can't even say, does E have a value or is E even, we could say it's well formed, right? What we were talking about yesterday. So you could say whether or not that type of error is going to pop up, but you can't even say if it gets the right type, right? Because you still need that X to be there. So good question. Well, you could, I suppose, give a type to the X and then you can type check this. So you can remove a bunch of errors, but you can never be sure it's, you could do checking, but we don't. For evaluation purposes, that's a whole different type of thing. We'll talk about that next week, right? I like how you're thinking. You're thinking then into the, how could this fail kind of thing, right? Cool. Online, any questions about this rule as I slowly scroll? Sweet. So we also had function calls, which took two expressions, right? This would be, expr function call, two expressions. How do we evaluate these? This is the harder rule to kind of get at. And it's going to have a couple different failure cases as well. So, but what happens if there's no error, we're not experiencing any problems? How should we expect this to behave? So we're going to write that similar boilerplate. We have some environment sigma. And then we have a function call. And we'll use E sub f for function, and then E sub x for, yeah, E sub x for the argument, right? And then our big evaluation error, what does this evaluate to? This one will need some premises. So let's start with this E of F. What should we expect E of F to be or evaluate to, right? So it should be a fundef? Maybe not necessarily.
Maybe just the expression part of the fund.
Right, so we do expect some function to be from EF, but we need to evaluate EF, right? Because otherwise it's just an expression. We don't want to make it a function definition, because what happens if it's like we're making a function call from somewhere else, it's in the environment somewhere. Say we did let F equal function, right? In that situation, it'd just be a variable, right? It'd be var F, right? So that doesn't quite work, but you're on the right track. What should we expect it to be instead of a function definition or maybe a variable name? We want to get the valuation. What's a valuation that we could use here?
Would it also be closure?
It would also be a closure, right? So here we would have sigma entails that E sub F evaluates to some closure and that closure has, again, some parameter, we'll call it P. Or actually, should we call it X? We should probably call that X. I don't see any reason why not. This could come back to hurt us later, but we'll call it X. X, we have some expression, which is the body. We'll just call it E sub B. And then we have some sigma prime. Okay, and that's whatever the environment was when we defined the function, right? That's that closure, kind of that the end closure.
Is like everything but like the new thing we're adding to sigma.
Well, it's the sigma back in time, right? So there might be a whole lot more in sigma. So I really ought to use, maybe we could call it sigma of F is maybe a better identifier for it instead of sigma prime, because prime usually denotes like with something else, right? Or some small change. So let's call that sigma F.
So it's this sigma or that's the environment the function was defined.
Right, right. It's from that closure. So whenever we built that closure, so we evaluated the function definition, it wrapped up the environment at that time. And now we're grabbing it. That's that sigma of F. And it's probably, in all likelihood, E of F was a variable, referring to something in the environment and saying, go grab this. And it was that. It had the closure all there. It could have also been a function definition inline, like we saw yesterday, how you can write function def and then immediately apply it. Could do that. But in that case, sigma and sigma F would be the same thing. So cool. Yeah, so I'm gonna give myself some more space here real quick. Very carefully. Let's do that. I'll give myself 2 lines. What else needs to be true? So we've evaluated E sub F. What else do we need to evaluate before we kind of say what function calls evaluate to? Yeah, we ought to do something with E of X, right? What ought E of X be? So we can start with that, sigma entails bit again. E of X evaluates to what ought it evaluate to?
Value.
It ought to be some kind of value. Does it need to be any particular kind of value?
No, I think it depends on the function.
Right, it's going to depend on the arguments. If it's a function on numbers, it should expect a number. It's a function on Booleans. It should take a Boolean, right? Or list. We'll add at some point in one of the homeworks, we add lists to the language. Yeah, so here we're just going to call it V. Nothing particular, it's just some V. Except that we're going to say one more thing about V. I do want to give myself just a little bit of room. We're going to say that V is not an error. Cool. For obvious reasons. If you get an error, you're going to fail out. So we'll have a different rule to handle that case. Clean that up a little bit. Now, what goes on the right-hand side of this arrow? What ought we put there? We've done everything else. Should it be V? Because V is the argument, right? So we have the argument, we have the closure, but how do we wrap it all together?
So like E of F of and parentheses V.
Can't quite do that because that's not notate. That's more in our concrete syntax. are we making an assumption in the premises up here that may not be true? Right, so like V not being an error, that's obviously handled by our error cases, right? What if, you know, this isn't true? This is kind of necessarily true. What if this isn't true? Well, we just handled that case. How could this maybe not be true? What could be false about that? EF evaluates to closure. Yeah.
Well, we could just, I mean, it could be anything.
Yeah, so what if it is not a closure? Yeah, it's like I say if you invoked, I said, let X equal 5, right? And I said, X of 7, right? Applied it like a function, that would be an error, right? Because it's not a closure, it's not a function. So yeah, so we have this other case where E of F doesn't evaluate to a closure. Let's try writing this rule out. So we'll have our, you know, similar boilerplate, sigma entails, fun call, E of F, E of X, down arrow, error. It'll have a different error string, so we'll wait for that. What goes on top, Colin, in your?
Yeah, like
Yeah.
it would be like E of F evaluates to.
So sigma entails E sub F evaluates to.
Probably like anything but a function.
Yeah, so we could write like V, and then maybe function def or what?
Well, it's like a closure.
Closure, right? So, and V is not equal to a closure. Kind of like how we did up here with error. Yeah, we just say V is not an error. Here, V is not a closure, right? What should we call this error? What if you tried to apply X to 5 or X to 7 and X is a number? What we would call that error? It's not quite it's not a function, right? It's not a function error, right? That's right, not a function. Close that out. And then let's give this guy a name. Let's try and make it the same size as the rule above. This will be interesting. This will be down, down arrow, fun call, not okay, 2. Could also have called it like not a function or NOF or not a function, something like that. If we want to give it a better name, we don't need to. Doesn't really matter a whole lot. We won't refer to these by name too often, but it is handy to give them names anyway. Is there anywhere else this could fail? And we already stepped through it, right? So if this assumption isn't true, this assumption will always be true. Why is that? You kind of took my word for it earlier. Are we asserting anything about what V of F is? No, we're just saying evaluate. We're not asserting anything about E of B other than that we have an E of B, right? That's kind of the same as V of F. Here, we're just kind of asserting we have stuff. We're not actually saying anything like X or say V has to be, say, a number or something. We're not making any assertions there about what it is. So that can't really fail. Where we see failures is when we say, okay, well, I had a variable and I'm forcing it to be a closure. So here, E of F, I'm assuming it's a closure. for this rule as a premise. That gives me a place, if I'm trying to write kind of a total set of rules that covers every case, that's a place where I need to go and define a new rule or case for, right? So if you think about this in terms of programming it, where you see departures like this, where it's not just a variable, but instead is something more specific, that's where you're case matching when you're programming this. Right, so if I was like trying to program this, I'd say, okay, well, evaluate E of F. I need E of F to be a closure, but what if it isn't, right? That's where you would case match and split and say failure here. It's an error because, you know, and you'd split those rules out. So we write multiple rules here, but when you write your interpreter for your homework, which is now due Friday, and the one you're writing right now doesn't have too many error cases, this is where those errors start to pop up, is really where we make an assumption in the premise about what something is, and it's not that. Well, which is why we can often leave the error cases out, because it's usually clear where they pop up. It's where we make an assumption that can't be met. Well, that's why this kind of premise followed by conclusion style is really useful. It's like, you know, we do this, but it also tells us how to program the interpreter with the top stuff as well. So something to think about. Yeah, there won't be like a quiz question or anything like that about that question, or about that point. Well, that hit all our inference rules. I'm trying to think if there's anything we need to cover before we wrap up. Yeah, before we start leaving, is anyone in the online section right now? Did anyone particularly have issues today with the midterm? Getting blank answers? Okay, Pseudo, I'll have you stay afterwards so you can help me fix the midterm. It should be hopefully a pretty quick fix. So for those of you that maybe came in late, we worked it out, the midterm. The reason it's not working, the reason we're having a short class today so I can fix it, is that when I fixed it yesterday, if you had already opened it, those blank answers got locked in as the possible answers for the problems. And so we need to basically create you guys a separate second midterm basically to take. Should be an easy fix. If you already submitted the midterm and there weren't any blank answers, you're okay, you're fine. Yeah, so if you took it basically after yesterday afternoon, you should be okay. And then if you haven't taken it yet, there will be 2 entries for it on Canvas. Take either one, it doesn't matter which. I'll put all this kind of typed out so you have a reference to it online on Canvas here in a few minutes. But otherwise, other than that, no quiz today. So we can just focus on the midterm, take that this afternoon or this evening, or into tomorrow. We will have a quiz tomorrow, but not for today into tomorrow, if that makes sense. So yeah, other than that, if anyone has questions about midterm type stuff, hang out. I'll answer those real quick before Pseudo and I fix that. Thanks for bearing with me, guys. That was a mess of trying to fix Canvas there, so appreciate it. Otherwise, have a good evening, and I will see you all tomorrow.
Thank you.